Note sheet. Everybody got a note sheet? Yes? Notes? Yes. Now, what we're doing today, or starting today, is Chapter 7. Chapter 7 is going to be over rational expressions and rational equations. And for the most part, we're going to have variables either in the top or bottom specifically, the bottom of the fraction, or it could be that it's in the top and bottom. But this here is a rational expression. We're going to have variables in the top or bottom of it. And we'll talk about simplifying and solving these rational equations. But before we delve too far into that, what we're going to start off with is inverse and direct variation. Now, direct variation, I've talked about a little bit in Algebra 1. Direct variation comes in the form of y is equal to a times x. As one of the variables increases, the other is going to increase. As one decreases, the other is going to decrease. They affect each other directly. So we do have y equals a times x. Or actually, we can say x is equal to a times y. A is just a constant amount. It's just a number. Or we could divide both sides by x and say that y over x is equal to a. So when we divide our y values by their corresponding x, we should get a constant term, a number, because they will relate to each other in a constant term. It's direct. Inverse variation, y equals a over x. Or we could say x is equal to a over y. I mean, these are the same equations, just another way to write it. Or we can get the a by itself, telling us that x times y is equal to a. These are all inverse variations, or different ways we can write this equation. Now, with inverse variation, as say x increases, the value of y is going to decrease because they're inverse. They're going to act in opposite directions. As one increases, the other is going to decrease. Or as one decreases, the other is going to increase. They're going to go in opposite directions by this constant amount, a. Questions on this here? All right. First thing we're going to do, tell whether it's direct variation, inverse variation, or neither. So if we look at the first one, x times y equals 5. Inverse. Because we're mainly going to look at the general forms and see which one is it. The other way is just to get the y value by itself and see how it relates. Because if we got y by itself, we would divide both sides by x. Telling us y is equal to 5 over x, or a over x, which would be inverse. What about b? Direct, inverse, or neither? It is actually neither. There's one thing that this has that direct and inverse don't have. Addition, subtraction. Direct and inverse variation will not have addition or subtraction. It's going to mainly deal with multiplication and division. So this is neither. Let's look at the last one. Y over 2 equals x is going to be direct. Now with C, there's two ways we can look at this. One is I can multiply both sides by 2, just telling me that y is equal to 2x. Because when we multiply y over 2 by 2, the 2 and 2 will become 1, giving us y by itself. So we get our y equals a times x. The other way to look at this is y over 2 is the same as saying 1/2 y. Y is on top, so we can move the 1/2 over. Does that make sense? It'd be different if it was 2 over y. That's y is on bottom. Y over 2 and 1/2 y are the same thing. Questions on this here? No? Okay. Because again, I'm just giving different ways to look at this here. But all three of these are direct. Let's look at the middle three. Number one, 6x equals y. This would be direct. Because y equals a times x, ax equals y. It just has it flipped. Y is equal to a times x. Does it make sense why one is direct? Let's look at number two. X times y equals negative 0.25. Inverse. Because this is our x times y is equal to a. A is just going to be a number. Doesn't matter if it's positive, negative, decimal fraction. It's just a. And the last one is indeed neither. The plus or minus kind of gives it away. Let's look at the last set of three. X times y equals 17. Inverse. All right, let's look at B. Y equals x plus 29 plus 29. Neither. C. This would actually be direct. Even though we do have the division, we can think of it as 1/10 times y is equal to x, because y is on top. We can move it over to the side. So we're multiplying the y by 1/10. This is a direct variation. So again, with most of these here, I would keep referring back to the general forms. Which one is it lining up with? Because a is just our variable, or not our variable, our number. The other way is just to get y by itself. So I can multiply both sides by 10, because those are going to go away. 10 over y. 10y divided by 10 is y. X times 10 is 10x. And the reason we do this is now this matches up with our y is equal to ax. So it is direct. It's just another way to verify that this is a direct variation. Questions on determining if an equation is direct, inverse, or neither? We feel good with these here, yes? All right. Now we're going to do it given a table of numbers, table of x and y values. Now direct variation. And inverse variation. Both of these, as we've seen already, have several different equations. Now there's a reason I'm picking these two, is because the variables are being related to each other. Because when we have a direct variation, y divided by x is equal to a. Or we can say x divided by y is equal to a. It equals that constant amount, that constant term. So if these sets of numbers are direct variation, when I divide the y values by the x values, I should get the same amount a if they vary directly. So we can start with this here. Our first y value is negative 2, or negative 12, and the x value is 2. What is negative 12 divided by 2? Negative 6. Okay, let's move on to the next one. Negative 6 divided by 4 is negative. Well, they don't divide evenly. Most we can do is reduce it to negative 3/2. Are those the same? No. So what can we say about direct? It's not direct because that amount has to be the same every single time. Inverse. X times y is equal to a is equal to that same amount. So we can start off with the first x value, which is 2, and the first y value, which is negative 12. And 2 times negative 12 is negative 24. And then we move on to the second one. 4 times negative 6 is negative 24. How about 6 times negative 4? Negative 24. And lastly, 8 times negative 3. Negative 24. So if we notice here, the a value, when we multiply the x and y values, is the same for all four, yes? Which means this is an inverse variation because we get the same value of a across all four. Any questions on A before we look at B? So we can look at B. So direct, y over x equals A. So we can start off with 2 divided by 1, which is 2. The next one would be 4 divided by 2, which is, well, this looks like it should be inverse, yes? Or sorry, not inverse, direct. 8 divided by 3. Well, that's not 2, is it? Because it's actually just 8 over 3, it doesn't reduce. But since it's not 2, well, that means that's not going to be direct. So it means it should be what? Inverse. Well, before we just say inverse, let's go on and verify. X times y is equal to a, yes? Our first one, 1 times 2 is 2. Next one, 2 times 4 is? It's neither. Specifically, this set of values actually lines up with 2 to the x. It's actually an exponential function. Because 2 to the first power is 2, 2 to the second, 2 squared is 4, 2 to the third power is 8, and 2 to the fourth power is indeed 16. It's an exponential function and increases faster and faster. But it is not direct or inverse. Questions on these so far? Tell whether these show direct or inverse variation. Now, we don't always have to start with direct. We could start with inverse. It doesn't matter which one we pick. You want to do direct or inverse first? Direct. So our y over x should equal a. We could use the other ones, but the main one I want is that the a is by itself. Because we do have y equals a times x, and we could use that. I want to write this down as an example. I wouldn't write it down. Because y is equal to a times x. Well, we would need to figure out what a is, so we would divide both sides by -4, telling us that a is -5. So the reason I use y over x equals a, or really you could also use x over y. It would also work, but we want to pick the ones where a is by itself. Does that answer your question on why we picked this one over the others? Yeah. We're wanting an equation that relates x and y to the given value, a. And 15 over -3 is -5. 10 over -2 is -5, and 5 over -1 is -5. So this is indeed direct. Now it does seem like they're going in opposite directions, but the x values are approaching 0, and the y values are also approaching 0. Questions on number 4 before we look at number 5? Do inverse. X times y equals a. 1 times 60 is Lo and behold, 60. 2 times 30 is 60. 3 times 20 is 60. And last one, 4 times 15 is so this is indeed an inverse variation. Questions on this here? Do you feel good about this so far? So we see another example of a set of x and y values figuring out the direct inverse. So good? Okay. Last thing we're going to look at. The variables x and y vary inversely, and y equals 4 when x is 3. Write an equation that relates x and y, then find y when x is equal to -2. This seems like a lot, but it's not a lot. Also, I'm going to emphasize this now, because if I don't, I feel like I'm going to have to hand back some assignments. Because again, the questions on the homework are going to be just like this. They're asking for 2 parts. They're asking you to write an equation that relates x and y. So we're going to have to write an equation and find y when x is -2. It happens every year. You will turn it in and just give me what the value of y is when x is the given value, which is on the homework is going to be 3. You'll tell me what y is when x is 3. You won't give me the equation. It happens every year. But if we look at this here, we want to write an equation where x and y vary inversely. Well, the inverse equation, our inverse variation, is y is equal to a over x. What is the only amount that we're missing from this equation? The number for a. Because once I get that value of a, I have the equation here. I just need to find the value of a. And they give us enough information here to find it. Because they say y is 4 when x is 3. There's 2 ways we can go about doing this. The first, replace y and x in the inverse variation. 4 is equal to a over 3. So to find a, we would multiply both sides by 3. Here, the 3 and 3 simplify, giving us a. 3 times 4 is 12. So our equation that we want is y is equal to 12 over x. So find y when x is -2. So y is equal to 12 over what? -2. So we just take that equation, plug it in, and yes, 12 divided by -2 is. So y equals 12 over x, y equals -6. Those are our 2 answers. So we need both parts. I can't just take y equals -6 because it does ask for the equation. But that's it. Questions on this here? We're ready for the next one. Variables x and y vary inversely. Y is equal to 8 when x is equal to 4. Write an equation that relates x and y, then find y when x is -16. So I'm going to show you another way that we can find a. Y is equal to a over x, yes? But how did we verify that it was direct or inverse, or divine, or show that it was inverse variation? We used what? X times y equals a, yes? This is still the equation for inverse, yes? So we're doing 8 times 4. So a is because we multiplied the x and y together, yes? So questions on this here. I'm going to go back one slide. Well, look at the previous one. What did we end up doing with the x and y? Yes? We could have done that from the beginning. Now we're not quite done. We still need to find what? The value of y when x is. So we have 32 divided by. So 32 over negative 16. We reduce it. We get y equals negative 2. If it doesn't reduce, leave it as a fraction. Questions on this here? We need to see another example of one of these. We feel good with these here? All right. That's it.